So you've got 2 fruit bowls in your house, and you're a good coder, so you decided, I'm going to take the fruits in those fruit bowls and put them into a Python list. Fruit bowl 1 and fruit bowl 2. And your mom says, what kind of fruits do we have? And you're like, well, in fruit bowl 1, we have an orange, a banana, an orange, an apple, an avocado. She says, stop! Why do you tell me about so many oranges? I just want to know what kinds of fruit we have. So you say, okay, well, I need to write some code to make another list that only has each unique type of fruit that I have in fruit bowl 1. But you don't actually have to, because we have a data type called a set that does that for us. And this is how we do it. We say fruit bowl 1 unique equals set fruit bowl 1. And then we'll print the result. What's fruit bowl 1 unique? Let's try that. Okay, so now we have a better answer. We can say, all right, Mom, we've got oranges, peaches, apples, pears, avocados, and bananas. So notice those are all the types of fruits that were listed in fruit bowl 1, but nothing is repeated, because in a set, every item is distinct. If we try to add 2 items of the same thing, Python just says, I'm just going to put 1 in there. So in this case, we had a list, which is an iterable, and we took that list and we used it as an argument in the constructor for the set object. We'll see that there's another way to create a set later. So now, great, let's do the same thing for fruit bowl 2. We'll print both, and now you say, okay, Mom, we've got in fruit bowl 1, apples, avocados, bananas, oranges, pears, and peaches. And in bowl 2, we have kiwi, apple, banana, orange. And she says, wait a minute, I don't need to know what's in bowl 1 or bowl 2. I just want to know what kind of fruits we have. Well, we have a solution for that too, because sets in Python are just like sets in math, and we have some of the same operations like unions, intersections. In this case, we'd like to take the union of both sets. That means all the items that are in set 1 and all the items that are in set 2, but don't repeat any of them. And we do that using the union operator, or the OR operator. And we say combined fruit bowl equals, and then each of our fruit bowl sets separated by the OR operator, which is the straight up and down line. Excellent. So now we can say, all right, in the 2 bowls combined, we have bananas, apples, grapefruits, pears, kiwis, avocados, peaches, and oranges. Notice that this set includes everything from the 2 sets, but no duplicates, like we only listed banana once and apple once, peach once, orange once. Now, Mom is very picky. She says, why do we have some fruits in both of the bowls? Maybe you can find out what fruits are in both bowls and give me a list of that. And you think back to your math class and you say, oh, that's the intersection. I want to know which items exist in this bowl and in this bowl. And in Python, we use the and symbol for intersection. So we'll say intersection equals fruit bowl 1 unique and fruit bowl 2 unique. And we'll print the intersection. We run that and we see that apples, peaches, oranges, and bananas exist in both fruit bowls. So we can take all the apples from one fruit bowl and put it in the other one, and etc. to make them distinct. Sets are iterable, but they're not ordered. So we can loop through a set. For item in combined fruit bowl, we can print the item. That'll give us a little nicer list of things that are in the fruit bowl. But we can't count on these coming up in the same order every time. Every time we run this, we'll see that they come up in a different order. Who knows why? We can use the length function, and we can use in. I mentioned that there were 2 different ways to define a set. We had a list, fruit bowl 1, which is iterable, so it was easy to define our set using the set constructor, placing the name of the iterable as the argument. But we can also define a set using curly braces. This still ensures that we have only unique items. Lemon is only listed once. But the difference here is that we listed individual items. We didn't put an iterable data type in here. And actually we can't. If we tried to put an iterable in here, like a tuple, the whole tuple shows up as one item. Notice that lemon showed up twice because lemon itself is not an item in this set. There's only one item in this set, and it's the entire tuple. Notice that I used a tuple here and not one of the lists that I had already defined. Let's try using the list. Of course, I'm not expecting each item to show up as an individual member in this set, because I know that using this curly brace form, that fruit bowl 1 should be placed in the set as a single item. But when I run this, I get an error. That's because a list is a mutable data type, and I'm not allowed to put mutable data types in a set. I can only put immutable types, like strings or tuples or ints or floats. Of course, the set itself is mutable. We've seen that we can change it easily. A couple more things we can do with sets. If we don't want to use things like the OR operator for simple operations, we can add items to a set using the add method. Of course, the item is only added if it didn't already exist in the set. We can remove items from the set, but if we try to remove an item that isn't there, we get an error. If we want to be able to remove items whether or not they're there, we use the discard method. If the item is not in the set, it just politely moves on. Finally, if we want to define the empty set, we just call the set constructor on its own. There's no way to define the empty set using curly braces because Python wouldn't know the difference between a set and a dictionary. There's a lot more you can do with sets. For example, you can ask if one set is a subset of another set. You can find the symmetric difference between two sets, which are items that are in one set or the other but not both. Take a look at the Python docs if you'd like to know more.